Welcome to Chemistry World. Today, let us discuss about the modern theory in chemical bonding, molecular orbital theory. In shortcut, we can say it as M.O.T, molecular orbital theory. It is the last theory in chemical bonding and modern or advanced theory in all theories of chemical bonding after hybridization and VSEPR theory. So many drawbacks are there in hybridization as well as VSEPR theory. So to overcome all the drawbacks, the latest theory was there, that is molecular orbital theory. According to this theory, for competitive exam purpose, please concentrate. For theory purpose, also it is basic concepts, and according to modern exams in modern theory and the current exams, mostly the questions come from this theory, indirectly or directly. So you should know the basic concepts of this theory. First thing, the main point of this theory is when a molecule is formed from the atoms by chemical bonds, atomic orbitals disappears. Remember, in hybridization, what is there? First, before molecule formation, in the central atom, the available orbitals in the valence shell first intermix each other and form a new type of orbitals known as hybrid orbitals, and the concept is known as hybridization. That hybrid orbitals will arrange in a particular geometry. Suppose if the hybridization is sp, two hybrid orbitals are formed in a linear geometry, and if the hybridization is sp2, three hybrid orbitals are formed and they are arranged in a trigonal planar geometry. If four hybrid orbitals are formed, if the hybridization is sp3, tetrahedral arrangement of four hybrid orbitals will be there, and if the hybridization is dsp2 or sp2d, four hybrid orbitals will be formed. In that four hybrids, they are arranged in a square planar shape, like that sp3d trigonal bipyramidal, sp3d2 octahedral, sp3d3 pentagonal bipyramidal, and if lone pairs are there, that shapes will be changed. That is hybridization and VSEPR theory concept. Coming to molecular orbital theory concept. So when a molecule is formed from the atoms, atomic orbitals disappears. A new type of orbitals are formed known as molecular orbitals. Means the first concept of this theory is when a molecule is formed from atoms. A molecule is formed from atoms. Atomic orbitals disappears. Atomic orbitals disappears, or atomic orbitals combined together to form a new orbitals known as molecular orbitals. That's why we will call it as molecular orbital theory. There are no atomic orbitals when a molecule is formed from atoms. If the atoms only are there, atomic orbitals like s, p, d, f are present. If the molecule is formed, no sp,d orbitals. A new type of orbitals will be formed and a new type of orbitals will be exist in the molecule. We will call that orbitals as molecular orbitals. So how are they formed? What are that molecular orbitals? Let me see now. When atomic orbitals are combined, that molecular orbitals formed by combination of atomic orbitals, that we called as LCAO. That concept is there. You can read from your books and once again go through the notes that will be there. LCAO means linear combination of atomic orbitals, means during molecular orbital formation, during molecule formation, atomic orbitals combine linearly and form a new type of orbitals. We call it as molecular. That combination of atomic orbitals is called linear combination of atomic orbitals. LCOO means two atomic orbitals combine each other and form two molecular orbitals. So during molecular orbitals formation, same energy orbitals combines, means 1s orbital of an atom combined with 1s orbital of another atom, not 2s, not 2p. Suppose in an atom 1s orbital is there, that only combine with 1s orbital of another atom and form two molecular orbitals. One is sigma 1s. Suppose if it is 1s orbital of one atom, it is atomic orbital. AO means atomic orbital. Here 1s atomic orbital of an atom, it forms two molecular orbitals. Why? Because that two molecular orbitals is called sigma 1s, sigma star 1s. Like that, two orbitals will be formed. These are called molecular orbitals. Generally, the orbital which is have the energy less than, suppose if we say it has the energy graph, it has the energy graph. So some molecular orbitals will be formed with less energy than atomic orbitals. The orbital which has less energy than atomic orbital is called bonding molecular orbital. Bonding molecular orbital. And the orbital, that molecular orbital which has more energy than atomic orbitals is called anti-bonding molecular orbitals. Anti-bonding molecular orbital. In shortcut, we can say it as ABMO and we can say it as BMO. Bonding molecular orbital, anti-bonding molecular orbital. Anti-bonding molecular orbital contains more energy than atomic orbitals. Bonding molecular orbital contain less energy than atomic. Why it has less energy? Why it has more energy? Means it will be formed by the combination of wave functions of atomic orbitals, that is addition of wave function of atomic orbitals, whereas antibonding molecular orbitals formed by subtraction of wave functions of atomic orbitals. That means suppose 1s orbital it is there, it is a minus pole this side, plus pole it is there, and another 1s orbital, if it is plus 4 is there, it is 1s pole is there. This plus and this plus when combined, that is called addition. By the addition of wave function of atomic orbitals, we get bonding molecular orbitals. They contains less energy than atomic orbitals. How much less? That is wave function psi a plus psi b whole square formula, you know, psi square a plus psi square b plus 2 psi a psi b will be there. That much of energy is less for this. So by the addition of wave functions of orbitals, bonding will be formed. By the subtraction, subtraction means what? Suppose here negative pole, this is positive pole is there for atomic orbital, and here negative pole, positive pole is there for atomic orbital. This positive and negative when combined, that is called plus and minus subtraction will be there. By that subtraction of wave function we get anti-bonding molecular orbital. It is psi a plus psi b whole square formula, and this is psi a minus psi b whole square formula we have to apply, because subtraction of wave functions give anti-bonding, addition of wave function gives bonding. You know the formula a plus b whole square formula, a minus b whole square formula. So it has that much of energy. 2 psi a psi b energy more will be there for anti-bonding, 2 psi a psi b level of energy less will be there for bonding molecular orbitals. Like that, atomic orbitals combine linearly. That's why we'll call it as LCAO, linear combination of atomic orbitals. Like this, when two atomic orbitals are combined, we get two molecular orbitals. We get two molecular orbitals. So once again I am saying the number of molecular orbitals formed in a molecule is equal to number of atomic orbitals involved. Suppose 10 atomic orbitals involved, we get 10 molecular orbitals. If 6 atomic orbitals are involved, we get 6 molecular orbitals. In that 10 molecular orbitals, 5 will be bonding, 5 will be anti-bonding. Means for every combination of two atomic orbitals, one bonding will be formed, one anti-bonding will be formed. So like that, two molecular orbitals will be formed by linear combination of atomic orbitals. So once again, in brief, I am saying, according to molecular orbital theory, when a molecule is formed from atoms, the atomic orbitals combine together and form a new type of orbitals known as molecular orbitals. Means in a molecule there are no atomic orbitals existence, only molecular orbitals existence will be there. That molecular orbitals, some will be bonding, some will be anti-bonding. That molecular orbitals formed by combination of atomic orbitals. When the wave function added, when the addition of wave function of atomic orbitals takes place, it gives bonding molecular orbitals. The energy is less than atomic orbitals energy. And if the wave function, subtraction of wave function of atomic orbitals is overlapping, anti-bonding molecular orbitals will be formed. Their energy is more than atomic orbitals. This is linear combination of atomic orbitals. This is main concept. Remember, by the addition of same signs will give bonding, subtraction of opposite signs plus and minus when combined, subtraction takes place, that gives anti-bonding. In diagrams, once again I am saying diagram, I can't write the diagrams here because it takes up so much of time. It's a waste of video time will be there. My suggestion, go through the books, any book you can take, reference books or textbook or any college books or notes, whatever maybe it is. The diagrams of molecular orbitals are formed. How sigma 1s will be formed, how sigma star 1s will be formed, how sigma 2s will be formed, how sigma star 2s will be formed. What is 2p 2pz sigma orbital, pi 2py sigma orbital, pi 2pz orbital, sigma star 2pz orbital, pi star 2py orbital, pi star 2p, how they are formed, what are their diagrams, is there in the textbook. Please go through that. Reading of textbooks is required in this situation. Remember, reading of every point in the textbooks is not the answer, is not the procedure for chemistry subject. NCRT based questions are there, NCRT based questions are there, like that so many will be say in their opinions during examination. My suggestion, NCRT is the textbook for subject, knowing of the subject, but knowledge of the subject will not be get from the NCRT book. It gives the quantity, this much of topic you have to learn, this much of knowledge you have to get from this topic, that only will be there. Getting of knowledge and getting of subject will not be possible only from NCRT. It will be possible to get so many reference books and so many classes, so many lecture classes you have to learn like this. So now M.O.Ts will be formed like that. This is diagram. Once again I am saying, please go through the textbooks to see the diagrams of molecular orbitals of sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2py, pi 2px, pi star 2px, pi star 2py, sigma star 2pz orbitals diagrams will be there. Anti-bonding orbitals will be formed by combination of plus and minus. Bonding will be formed by combination of plus or minus. Plus minus depends upon the direction only. This side plus means this side minus will be there. If you go this side, it becomes plus, this becomes minus. So that is not the thing. So same magnitude, if it is up here combined, bonding opposite things, opposite wave functions are combined, that will give anti-bonding molecular orbitals. So this is introduction of molecular orbital theory. After that, let me write how we have to write molecular orbitals for different molecules. How we have to write molecular orbitals for different molecules. Let me see now. Writing is very easy. It is not tough. Let me go for simple example to tough example. Up to 14 electrons, the energy of order of molecular orbitals will be in one type. After 14 electrons, whatever the molecule it is ion or molecule or whatever, positive ion or negative ion or neutral molecule, up to 14 electrons, arrangement, energy order of molecular orbital is one thing. After 14 electrons, the energy order of molecular orbital is another thing will be there. Let's go for first simple example. Simple example of molecular orbital theory. MOED of H2, let me see. Full form of MOED means what? Molecular orbital energy diagram. Molecular orbital energy diagram of H2, let me see now. So this is the molecule formed by combination of two hydrogen atoms. This hydrogen has 1s1 configuration, this hydrogen has 1s1 configuration, means one electron is present in 1s orbital, one electron present in a 1s orbital. So this one electron, this one electron, means this orbital will combine together and to form two molecular orbitals like this. This is 1s orbital of hydrogen, and this is 1s orbital of hydrogen. This is atomic orbital 1s, this is 1s atomic orbital of hydrogen. Then we get one molecular orbital by combination of wave functions, and another one is another anti-bonding. This is ABMO we get, and this is BMO we get. BMO we get. We can say it as sigma 1s. We can say it as sigma star 1s. Why we are saying it as sigma? Sigma star means atomic orbitals overlap in straight wise only. Straight overlap only possible, no side by side chance. That's why sigma. When atomic orbitals overlapping, we get sigma bond only, no pi bond. So sigma bond will be formed. That's why we get sigma 1s bonding molecular orbital by the combination sigma star 1s anti bonding molecular orbital by subtraction of wave functions. So here it has only one electron, here it has only one electron. So after disappearing of atomic orbitals and after formation of molecular orbitals, electrons arrangement takes place in molecular orbitals as per electronic configuration rules. There are three electron configuration rules are there. One is Above principle, one is Hund's principle, one is Pauli's exclusion principle. That rules will be followed by these molecular orbitals also, means electrons arrangement will be there in molecular orbitals based on the three principles. How we use for that? Filling of atomic orbitals in an atom. In an atom, how we use the three rules to fill the electrons in atomic orbitals, same rules will be there to fill the electrons in molecular orbitals. Means lower energy orbital will get low first electrons, after that electrons have to be filled in higher orbital. Lower energy orbitals are filled first, and then remaining electrons goes to higher energy orbitals. Here one electron is there, here one electron is there. So two electrons will be arranged in this only. No electrons in anti-bonding molecular orbital in a H2 molecule. In H2 molecule, no electrons. Why? Because two electrons filled here itself, no more electrons to go to anti-bonding molecular orbital. This is MOED. If we write the configuration for H2, so sigma 1s has two electrons, sigma star 1s doesn't have any electrons. This is energy electronic configuration of H2 molecule according to molecular orbital theory. Then we have to write bond order. This is bond order. Please remember bond order. How we write the bond? Actually, bond order means what? Number of bonds between atoms. Number of bonds between atoms is called bond order. How many bonds are there between two atoms is bond order. That is be calculated by the formula. We can say that bond order simply as BO. Bond order will be calculated by the formula 1 by 2 into NB minus NA. NB means number of electrons in a bonding molecular orbital. Na means number of electrons in a anti-bonding molecular orbital. In this H2, this is bonding molecular orbital, this is anti-bonding molecular orbital, sigma star it is. So in bonding molecular orbital, we have 2 electrons. That's why 1 by 2 into 2 minus no electrons in anti-bonding. So 2 minus 0. So that is 2 minus 0 means 2. 2 by 2 means what? 1. That is between two hydrogen atoms, one bond is present. That is called bond order. Only one bond, that one bond will be sigma bond will be present in a H2. So this is bond order. After that, we have to discuss about magnetic nature. It is important in molecular orbital theory. Magnetic nature. Magnetic nature always depends upon unpaired electrons. If the molecule, after arrangement of electrons in molecular orbitals, if it has unpaired electrons, it is paramagnetic. If unpaired electrons are present, unpaired electrons are present after molecule formation, not before molecule formation. After filling of electrons in molecular orbitals, in that molecular orbitals, if we have unpaired electrons, that molecule is paramagnetic. Molecule is paramagnetic. If no unpaired electrons, if no unpaired electrons in molecular orbitals, only molecular orbitals, don't consider atomic orbitals. Once again I am saying these two electrons disappear after forming electrons here. There are no atomic orbitals. Once the molecule is formed, atomic orbitals will be disappeared. Remember, so no electrons here. The two electrons only going here because these molecular orbitals forming from the atomic orbitals only. Once the molecular orbitals form, atomic orbitals disappears, electrons in atomic orbitals disappear. Only molecular orbitals will be present. So, if no unpaired electrons in molecular orbitals, if no unpaired electrons are present, no unpaired electrons are present, that is molecule is diamagnetic molecule. Diamagnetic. In this H2 molecule, sigma 1s2 means pair is there, no unpaired electrons. So in H2 no unpaired electrons, no unpaired electrons, therefore it is diamagnetic. Diamagnetics, repelled by the magnetic field when H2 molecule is placed in the magnetic field. Actually diamagnetic means what? When the magnetic substances or any substance is placed in the magnetic field, if it is repelled by the magnetic field, that is called diamagnetic. That is possible if doesn't have any unpaired electrons in the molecular orbitals after molecule formation. In H2 molecule, only 2 electrons, that will be present as a pair, so no unpaired electrons, it is diamagnetic. So this is M.O.T of H2 according to molecular orbital theory. Remember, briefly I am saying, for competitive examination purpose, for theory purpose also, after listening this class, just go through your class notes or go through your material, any reference material or any books. Just read one time, you will get complete idea. But I am saying here the complete information how to identify molecular orbital and how to understand molecular orbital. Once again I am saying, according to molecular orbitals, there are no atomic orbitals availability after formation of molecule. They will be disappear. Only molecular orbitals will be present. The number of molecular orbitals present in a molecule depends upon number of atomic orbitals involving in the bonding. Remember, up to hybridization and VSCPR theory concept, only valence shell electrons, valence shell orbitals means outermost shell electrons, outermost shell orbitals only participate in chemical bonding. But according to molecular orbital theory, it is wrong. All orbitals from 1s to highest valence shell, whatever the number of shells are present, all atomic orbitals from 1s involve in bonding. According to hybridization concept or valence bond theory, previous concepts of chemical bonding, inner shells orbitals, inner shells electrons never participate in chemical bonding. Only valence shell orbitals, valence shell electrons involved in chemical bonding, hybridization or chemical bond, whatever. But here, according to molecular orbital theory, it is wrong. Not only valence shell orbitals, not only valence shell electrons, all orbitals, all electrons of atoms from oneness, all orbitals from oneness involved in bonding. So after involving that one, we get molecular orbitals, all atomic orbitals will be disappear. After forming molecular orbitals, electrons have to be filled in that molecular orbitals based on three rules. After writing electronic configurations, we can identify bond order like this by the formula Nb minus Na by 2. Nb means number of electrons in bonding molecular orbital. Na means number of electrons in anti-bonding molecular orbital. Based on that, I have calculated bond order. Bond order nothing but number of bonds between the atoms. So that we have calculated here between two hydrogen atoms, we got one bond, means single bond is present between two hydrogen atoms according to M.O.T. And after writing all these things, if you observe the electronic configurations of molecular orbitals, if molecular orbitals have unpaired electrons, that molecule is paramagnetic. If that molecular orbital does not have any unpaired electrons, that molecule is diamagnetic. In this case of hydrogen, no unpaired electrons, only paired electrons present in bonding molecular orbitals, so H2 is diamagnetic. Like that we have to go for examples. Now let's go for next example in a next video, because already it has been 28 minutes or 27 minutes so is there. So please go through once again this theory back. Only one concept: all atomic orbitals from oneness involved in bonding during molecule formation. When the molecule is formed, atomic orbitals disappear, only molecular orbitals present in the molecule. In that molecular orbitals, electrons are filled based on the three electronic configuration rules. All the molecular orbitals can be divided into two types: bonding molecular orbitals, anti-bonding molecular orbitals. Bonding molecular orbitals are formed by addition of wave function of atomic orbitals. That is, suppose A atom, B atom are combining, psi A plus psi B whole square formula will be there for that bonding. And anti-bonding will be found by subtraction of wave functions of atomic orbitals, that is psi A minus psi B whole square formula we have to use. That's why bonding molecular orbitals contains less energy, anti-bonding molecular orbitals contain more energy. This is the procedure to calculate M.O.E.D. M.O.E.D. means molecular orbital energy diagram. So next example, let me go for next video. Thank you.